Hi everyone. In this video we are going to discuss about how to find the distance between the circumcenter and the incenter of a triangle. Let's suppose we have a triangle ABC where the angle BAC is denoted by uppercase A radian, angle ABC is denoted by uppercase B radian, and angle ACB is denoted by uppercase C radian, and also the side length AB is denoted by lowercase c units, side length BC is denoted by lowercase a units, and side length AC is denoted by lowercase b units. So for this triangle, let's first draw a couple of perpendicular bisectors to find the circumcenter. Here I have drawn the perpendicular bisector for the side BC and side AC, and the two bisectors intersect each other at point O, so that is our circumcenter for this triangle. Next, let us find out the incenter. For that, I am going to draw a couple of angle bisectors here, and let's suppose I is the incenter, where the bisector of angle B and angle C, they intersect at point I, and that would be our incenter. And if we join the points I and O, we have to find the distance IO. That is the main topic of discussion in this video, how we are going to find the distance IO. Now, to be able to find the distance IO, we have to use a triangle, some sort of a triangle where IO is one of its sides. And for that, what I'm going to do, I'm going to join BO and CO. So BO is equal to CO is equal to the circumradius of this triangle. And now we have a nice triangle, which is triangle IBO. Using that triangle, we should be able to find the side length IO, because we know the distance of a vertex from the incenter, and in this case if we take B as the vertex, so this distance IB, that will be equal to 4 times R times sine of C over 2 times sine of A over 2. We have seen that in a previous video. I have shared the link in the description. Feel free to watch that video. So the distance of vertex B from the incenter is equal to 4 times R times sine of C over 2 times sine of A over 2. Also, we know that BO or OB, that is actually the circumradius, which is being denoted by uppercase R units. And now if we can somehow figure out the angle IBO, then we should be able to use the cosine law on this little triangle to find the length of IO. So let's try to find out what is that angle IBO. Now, before we go into the calculation of the angle, let's also quickly make a couple of notes here. We know that Inradius of a triangle is denoted by 4 times R times sine of A over 2 times sine of B over 2 times sine of C over 2. We have proved that already in a previous video. I have shared the link in the description of this video as well. Feel free to watch it. Now let's go and somehow try to find out what is that angle IBO. We know angle IBC would be half of B, because BI is the angle bisector. So angle IBC will be B over 2. And now let's try to find out what is the angle OBC. Now to find out the angle OBC, we have to focus on this little triangle, which is triangle OBF. And if we look at that triangle carefully, angle BOF is actually equal to A. Why? Because triangle OBF and triangle OCF, they will be congruent triangle, since OF is the perpendicular bisector of the side BC and OB is equal to OC, that is our circumradius. So then these two triangles will be congruent triangles, and then definitely angle BOF and angle COF, they will be equal. If you look at the circumcircle, which kind of looks like this, then BC is a chord that is subtending the angle BOC at the center, and it is also subtending the angle BAC on the circumference. We know that a chord in a circle subtends twice the angle at the center than it does on the circumference. So the angle on the circumference, which is angle BAC, that is equal to A, uppercase A radian. So the angle BOC will be 2 times A, and that means angle BOF will be just A, and that will also be equal to angle COF. So let me make a note of that here. So if we now think about this little triangle OBF, we know that angle BFO is actually a 90-degree angle, because it's a perpendicular bisector there. So angle OFB or angle BFO, that will be 90-degree. And now also we have figured out that angle BOF is A. So angle OBF will be equal to 90-degree minus A. Think about it, because in a right triangle, we know that one of the angles, which is angle BOF, that is actually equal to A. So then the other angle, which is angle OBF, that will be equal to 90-degree minus A. So then what will be the angle IBO? Well, then we can say that angle IBO will be equal to angle IBC minus angle OBC or OBF. Now, what is angle IBC? Well, angle IBC is actually half of the angle B, because IB is the angle bisector there. So angle IBC will be half of B, that is B over 2, and minus what is angle OBF? Well, we just found the value of OBF. That angle is now looking like 90 degree minus A or pi over 2 minus A. So that would be B over 2 minus pi over 2 plus A. So this can be written as B over 2 minus, in place of pi over 2, can we write A over 2 plus B over 2 plus C over 2? Because we know that the sum of the three interior angles of a triangle is equal to pi radian, and half of that would be pi over 2. So in place of pi over 2, I am writing A over 2 plus B over 2 plus C over 2, the sum of half of A and half of B and half of C. And then of course we had a plus A here, and if we simplify this a little bit, this will be B over 2, and if we remove the parenthesis, then we have minus A over 2 minus B over 2 and minus C over 2, and of course we have plus A, and here you see this B over 2 and B over 2, they will cancel out each other. So essentially we are left with A minus A over 2 minus C over 2. So that is actually equal to half of A or A over 2 minus C over 2. So that is the value of the angle IBO, and I'm going to make a note of that up here. So angle IBO is actually equal to A over 2 minus C over 2. Now we are going to play with this little triangle IBO, and there we are going to use the cosine law. So let's try that. We already know IB is equal to 4 times R times sine of C over 2 times sine of A over 2, and also we know that OB is equal to uppercase R, which is the circumradius. So we know the two sides, and also we know the angle contained between those two sides, so we should be able to use the cosine law here, right? So let's use the cosine law on this little triangle. So from triangle IBO, on this triangle I am going to use the cosine law on this angle, which is angle IBO. So we can say that cosine of angle IBO will be equal to IB squared plus OB squared minus IO squared over 2 times IB times OB. And now let's plug in the values here. We know that angle IBO is equal to half of A minus half of C. So A over 2 minus C over 2. So that's what I have written here. So on the left hand side we have cosine of A over 2 minus C over 2 is equal to, on the right hand side we have IB squared. Now what is IB? Well, IB is actually 4 times R times sine of C over 2 times sine of A over 2, and that is our IB squared. Plus what is OB squared? Well, that is actually uppercase R squared, that is the circumradius, and then minus IO squared over 2 times we have IB. Now again, what is IB? IB is actually 4 times R times sine of C over 2 times sine of A over 2, and times we have OB. OB is actually uppercase R. Now let's cross multiply. Then on the left hand side we are going to get cosine of A over 2 minus C over 2 times, here we have 4 times 2, that is 8, and then R times R, that would be R squared. So that would be 8 times R squared times sine of C over 2 times sine of A over 2, and that will be equal to, on the right hand side we are going to have 16 times R squared times sine squared of C over 2 times sine squared of A over 2, plus we have R squared minus IO squared. Next, what I am going to do, I am going to bring IO squared to the left hand side and bring everything from the left hand side to the right hand side. So on the left hand side I am going to keep IO squared because that is the value we are going to calculate here. So we can say IO squared is equal to, on the right hand side we have an R squared, so I am going to keep that as is. So that is R squared plus 16 times R squared times sine squared of C over 2 times sine squared of A over 2, and here from the left hand side we are going to bring this quantity, which is actually 8 times R squared times sine of C over 2 times sine of A over 2 times cosine of A over 2 minus C over 2, and in the next step what I am going to do, I am going to expand this cosine of A over 2 minus C over 2. So we can write it like this, and next I am going to remove the parenthesis, and then it is going to look like this. and then you can see that we have positive 16 r squared times sin squared of c over 2 times sin squared of a over 2, and we have a negative 8 times r squared times sin squared of c over 2 times sin squared of a over 2. So that will bring it down to 8 times r squared times sin squared of c over 2 times sin squared of a over 2. So we can write it like this. And in the next step, I am going to take 8 times r squared times sine of c over 2 times sine of a over 2 as a common factor. So we can then write it like this. And then if we multiply by a negative 1 inside the parenthesis and outside the parenthesis, then we can write it like this. And from here, you can clearly see that the quantity inside the parenthesis is actually cosine of c over 2 plus a over 2. So we can then write it like this. And in place of c over 2 plus a over 2, can we write pi over 2 minus b over 2? Here I have a little note. As you can see that a plus b plus c is equal to pi radian. So a over 2 plus b over 2 plus c over 2 will be equal to pi over 2. And so we can say a over 2 plus c over 2 is equal to pi over 2 minus b over 2. And that's exactly what I'm going to substitute there. So then we can write it as r squared minus 8 times r squared times sine of c over 2 times sine of a over 2 times cosine of pi over 2 minus b over 2. Now cosine of pi over 2 minus b over 2 is actually equal to sine of b over 2, because that will be the complementary ratio. Cosine of 90 degree minus any angle is equal to sine of that angle. So here then in place of cosine of pi over 2 minus b over 2, I am going to write it as sine of b over 2. So then this expression can be written as, and then can we also write it as r squared minus 2 times r times 4 times r times sine of a over 2 times sine of b over 2 times sine of c over 2. And this quantity on the right hand side here, this quantity is actually equal to lowercase r, which is the Inradius. So then we can clearly say that this quantity is actually equal to r squared minus 2 times the circumradius times the Inradius. And this quantity is actually IO squared. So here I can say IO squared is equal to that quantity, and from here we can then say that IO is equal to square root of r squared minus 2 times r times the lowercase r, and this is the distance between the circumcenter and the incenter of a triangle. I hope everything made sense. Thank you for watching. See you in the next video.